Hello, class. I was informed by your classmates that for some reason the volume did not record with the last recording for sections 3.8 and 3.9. So I'm going to go over them right now. Okay, so I'm starting with section 3.8 on page 343. I'm going to do the exact same problems I did before, which was just problems 2 and 4. So with problem number 2, so we have 2a, we have log of 1 over 1,000. Now with log of 1 over 1,000, basically when you look at this log here, this is basically equal to x because I'm going to show you what we'll be thinking. And then I will show you how to do this also in the calculator. When you don't see a base here with the log, that base is assumed to be 10. So basically we're saying 10 to some power is equal to 1 over 1,000. Now if we change this 1 over 1,000, we can make this 1,000 to the negative 1 power. Now we could change this 1,000 to 10 to the third power, take it to the negative 1 power. Now this would be 10 to the x is equal to 10, a power to a power, you multiply the exponents, and that'll be 10 to the negative 3. Now that we have the same base, we could just set the exponents equal to each other. And that would take care of that as far as doing it by hand. Now on the calculator, if you click here, you click the keypad, you will go to functions, miscellaneous, and then you will go down here to log. And then you could type in 1 divided by 1,000. And your answer here would be negative 3. So the answer to 2a log of 1 over 1,000 is equal to negative 3. Okay, now we go to 2b. Now 2b, we have log 1 over 100, which is basically the same concept. In our mind, we're thinking this is equal to x or some unknown value. This base is considered to be 10. So it'd be 10 to the x is equal to 1 over 100. So it'd be 10 to the x is equal to, this would be 100 to the negative 1 power. We could change 100 to 10 to the second power. And that's taken to the negative 1 power. So it'd be 10 to the x equals 10 to the negative 2 power. Same base, we just set the exponents equal to each other. Now here in the calculator, all we have to do here is just take away one of the zeros, and it gives us a negative 2. So that's B. Now C, we have log 1 over 10. I'm not going to put this, I'm not going to do this by hand again. So it'll just be negative 1. You can do that right in your calculator. Now D, we have log of 1. Now I want you to look at this. We know the base here is 10. So we're asking ourselves 10 to what power would give us 1? So it gives us some unknown value. 10 to the x equals 1. We know 10 to the 0 power. So x will have to equal 0 because we know 10 to the 0 power would give us 1. So your final answer here would be 0. Now we go here to E. We get log of 10. Now I want to show you something. When you have a situation when the base and the argument are the same. In this situation, we notice here that we don't show our base, which we know is 10. So when the base and argument are the same, it equals 1. Because these simplify out and leave you 1. Or if you want to rewrite this in exponential form, we'll do to the x, so it'll be 10 to the x is equal to 10. And remember that 10 is taken to the first power. Same base, we set the exponents equal to each other. Now, one thing I did negate to do, and let me do that real quick. I didn't go over the general form of log. It'll be log base B of A is equal to C. Now, B is the base, and A is the argument, and C is the exponent. Okay, now, when we rewrite this as an exponent, we would take the base B to the power of C, and it's supposed to give us A, which is basically what we've been doing here. So we're going to move on to F. So we have log 100. Remember that base is 10. So we want to find what C is, which is the exponent. So it'll be 10 to the C is equal to 100, because we're trying to make this argument. 100 rewritten in exponential form is 10 to the second. We have the same base, and C is 2. So our final answer here would be 2. Now we go here to G. We have log of 1,000. So we can ask ourselves, 10 to what power is 1,000? We know that's 3. So we could do here, we could go back here and press log of 1,000, and it's 3. Now we have H, log square root of 10. Now remember, this base here is assumed to be 10, so it'd be 10 to some unknown value is equal to the square root of 10. Now we could rewrite a square root into an exponent, and it'd be 10 to the 1/2 power. So that would leave us x equals 1/2, or the value that we have would be 1/2. Now that's problem number 2. Now we're going to move on to problem number 4. Number 4, it says rewrite the following equations in exponential form. So for A, we have log base 3 of 81, and is equal to 4. So remember, it's base 3 to the 4 is equal to 81. Okay, B, we have 1/2. 1/2 is equal to log base 100 with the argument of 10. So this would be 100 to the 1/2 power is equal to 10. So now we move on to C. Log base 9, the argument n is equal to 12. So we know we would take this to 9 to the 12th power is equal to n. So D, we have y is equal to log base 7 of x. So it'd be 7 to the y power is equal to x. So now we go to E. We have the natural log of the square root of E is equal to 1/2. Now, natural log has a base of E. So this is really E to the 1/2 is equal to the square root of E. Then finally, F, we have a natural log of 1 over E squared is equal to -2. So this would be E to the -2 is equal to 1 over E squared. And that takes care of section 3.8. Now we're going to move on to section 3.9. And that starts on page 350. And remember, we're going to do problems 2 and 4 as well. So now, problem 2, it says complete the following table using your calculator. Round your answers to the nearest 10th. Okay, so now that we know this, so we need to draw this table for 2A, and we need to complete the table. So we have x and y equals log x. And we have, let's see these numbers. We have 0.001, 0.01, 0.1, 0.25, 0.5, and then also 1. Now it says complete the following table using your calculator. And I already read this about rounding your answer to the nearest 10th. So we could put this right here in our calculator. So we could do y is equal to log x. Close that parenthesis. Okay, so we have y equals log x. We can hit this plus sign. Oh, no, we hit the wheel. You hit the wheel and you hit the table. Now all we need to do is put these values in. If you notice, we already have 1 in, so we could put that for 0. So then we could put in, what's that, 0.5? 0.5 is a negative, it'd be negative 0.3 because we're rounding to the nearest 10. So we'll do 0.25, and it'll be a negative 0.6, and then 0.1, that'll be negative 1, 0.01, be negative 2, and then 0.001, which would be negative 3. Okay, now that took care of A. Now we go to B. It says as the positive input values take on values closer to 0, what happens to the corresponding output values? The output values become very large negative numbers. Now, when I say large, we know as negative numbers get further and further from 0, they're technically getting smaller. So what I'm talking about is large in absolute value. So as the numbers get larger as far as negative for absolute value, like we know negative 3 absolute value is 3, which would be greater than 0, and so on. That's what I mean by that. Okay, C. It says determine the vertical asymptote of the graph of y equals log x. Now the vertical asymptote basically goes like this. We know asymptotes just basically means that we're trying to find when the slope is undefined. That's basically what an asymptote is basically showing us. So if we look here, log of x, basically x will be equal to 0. When x is 0, or basically when we look here, when x is 0, then we will have our vertical asymptote. Because if you look here at this graph, when x is 0, it never really hits the y-axis. And then another thing too, if you notice, when x is 0, is undefined. So anything 0 or less would be undefined. So we'll put it x equals 0. And then we can also put the y-axis, because the reason being is that's in line with x equals 0. Because anything that we put on the y-axis would make x 0. And we know y would never equal a negative number. So x is equal to 0. So now we go here to problem number 4. So we have 4a. It says using a graph of y equals, let me write that down, y equals the natural log of x. As a check, summarize the following properties of the natural logarithm functions. What is the domain? Okay, now I'm going to do this here. Let me just take all of this off. we're going to do y equals natural log of x. Now, if we look here, this is the graph of y equals the natural log of x. Now, they ask us what is the domain. If you notice here, the domain is the x values. This graph will never hit where x is 0. And it also won't hit the y-axis either. It'll get very close, but it will never hit it. Because if you notice here, the natural log of 0 is undefined. So it can never hit this y-axis or where x is 0. So your answer here for 4a would be x is greater than 0. X would be greater than 0. Now we go to 4b. What is the range? The range is the y values. There's no restriction on the y values because if you notice, this is going down forever and this is going to be going upward forever on the y-axis. So it'll be the set of all real numbers. Okay, now we go to C. For what values of x is the natural log x positive? Now, if you notice here, they ask us when is y equals the log natural of x positive. So if you notice here, at x equals 1, y is 0. And we know 0 is the midpoint between positive and negative numbers. So it has to be all numbers greater than 1. X value is greater than 1. So D, for what values of x is the natural log negative? So first of all, you notice here to be values less than 1, but x would not go past 0. So it'll be 0, x will have to be greater than 0, but also less than 1. Because it's in between these values here. It'll never hit where x is 0, and then also we wouldn't count where x is 1. It's in between those values. Now we go here to E. For what value of x does the natural log x equal 0? And we have that here. When x is 1, natural log x is equal to 0. So it'll be x equals 1. Now we go to F. For what values of x does the natural log equal to 1? Okay, so now let's take a look here. Natural log base is E. Now I told you all earlier, when your base and your argument are the same, so if this is x, natural log E of x is supposed to equal 1. When your base and argument are the same, it automatically equals 1. But what I want to do is show you this here by rewriting this as an exponent. It'll be e to the first equal to the x, equal to x. E to the first is e, and it equals x. So that would be your final answer. Or you can remember, natural log with the same base simplifies out and equals 1. So your answer here would be x is equal to e. Okay, and that concludes sections 3.8 and 3.9.